All right, what's going on, my fellow physicists? Today I'm going to be conducting a very short presentation on velocity. We're going to talk a little bit about what velocity is and what it isn't. So first of all, velocity is a vector. It is not a magnitude, so let's keep that in mind. So what is velocity? We need to understand what makes up velocity. So speed is described by the distance that an object has traveled divided by the time it took the object to scale its distance. Displacement, on the other hand, also known as change in position, is described by an object's final position subtracted by the object's initial position. So velocity essentially is described by an object's displacement divided by the object's change in time. And because velocity portrays speed and direction, it is therefore a vector and not a magnitude. So here is a simple graphed example. We have displacement in meters over time in seconds. And we could assume that whatever object is being graphed here, it is moving forward. So let's keep that in mind. So the displacement in meters, we could see it goes, let's see, 10, 20, 30, 40, 50. So we can see in this graph, the slope of this graph would actually be 5 because 10 over 2 equals 5. Displacement in meters would be 10 meters for every 2 seconds, which we can just simplify to 5 meters a second forward. So 5 meters per second forward would be the velocity of whatever object is depicted in this graph. So here are some written examples of velocity. So a family travels via car 18 kilometers an hour north of their home. A tortoise is hungry and decides to travel 55 feet per minute south of its original position to find food. The plane traveled 575 miles per hour north of Los Angeles. So these are examples of velocity because they display the speed, kilometers an hour, and then they also display the displacement. So direction, sorry. They display the speed and the direction. So the direction would be north in this case, and the speed here would be 55 feet per minute, and then direction is south. So all of these here describe velocity. Now down here, a western honeybee flies approximately 19.5 miles per hour to a flower. Listen, I don't know where this honeybee is coming from. It could be coming from the floor. It can be coming from the sky. I have no idea because there is no direction here. All I know is that it's flying 19.5 miles per hour to a flower. So this is not an example of velocity. A Garibaldi damselfish, which can be found on our coast, can swim at a speed of approximately 1.5 body lengths per second. This is also an example of a not velocity because, I mean, I don't know where it's swimming, when it's swimming. It's literally just a fact here. But it does not display any form of direction at all. I mean, it says it can be found on our coast, but that doesn't tell us where it's swimming to. But yeah, that's pretty much it. And one thing, I don't know if I went over this yet, but essentially the slope of this line, the slope of this graph is the velocity. So keep that in mind in the displacement over time graphs. It's pretty easy to find velocity because it's literally the slope of the graph. All right. Thank you for listening and watching. I appreciate it.